Okay, so let's look at the second page of the review here. So let me just close this. I need the second page. Can I get the second page? I think I can open up the second page from here. All right, so okay, let me move this a little bit to the side. Okay, so let's look at this question. I hope you can see it. All right, let me make it a little larger. All right, good. I think that's good enough. All right, so question number 18, all right, 18. We have the compound interest formula, which is A equals P times 1 plus R over N to the power of N times T. And so the principal that you're investing is 20,000. Interest rate is R is 5%. So that's equal to 5 over 100. It's equal to 0.05. Compounded quarterly, so N is equal to 4. How much will it be after 4 years? So T equals 4. So by substituting, you'll get A equals P, which is 20,000. 1 plus R is 0.05 over N, which is 4 to the power of 4 times 4. Here, 4 times 4 as an exponent, you got to put 16, or you put a parenthesis over here. Otherwise, you wouldn't get the answer when you substitute into the calculator. So you get 20,000. 1.01, remainder is a 1, so 10 is a 2. Remainder is a 2, so it's a 5. So it's 1.0125 to the power of 16. Put all of them into your calculator. I think I have a calculator open up here for you. So let me see if I can do that. Let me see if I can open up the calculator for you. All right. So yeah, there's most calculator. So I'm going to put the calculator here. So I'm going to put, let's see if I can type. Can I type in the answer? Yeah, I think I should be able to. Oh, yeah. Okay, can I type this in? How can I type it? I guess I have to type it from here. Okay, so I get 20,000 times, so multiply by, do I have a parentheses? I guess I can press this one in here first. Okay, no, I guess not. So press 1.0125 to the power of 16. So I get an answer of 24,300 and something dollars and something cents. Let me just make sure the answer is correct. This is question number 18, I believe. So $24,397.79 is perfect. So let me write that down. So the answer is $24,397.79 for dollars and cents. All right, so let's go back to our question here. Let me see if I can minimize this. I think that should take it to where we were at. All right, great. Okay, so that's the answer for question number 18. Let's look at, see if I can do 19 at the same time here. So we want to solve for x. So we have log base 8 of x equals 4 over 3. Now remember, if you have log base b of x is equal to y, you could write this in exponential form as b to the power of y, b to the power of y equals x. So that one more time, it's going to be b to the power of y equals x. So this one is going to be equal to 8 to the power of 4/3 equals x. So now how do you simplify 8 to the power of 4/3? That's, remember, as I told you, if you have b to the power of m over n, it's the same as nth root of b to the power of m. You can put the m inside or outside. I think I like it to have it outside. So it's cube root of 8 because you can simplify it and then the number gets smaller to the power of 4. Cube root of 8, 8 is 2 to the third power. So cube root of 2 to the third power, this cancels out. So it's going to be a 2. So 2 to the power of 4 is going to be 2 times 2, which is 4. 4 times 2 is 8. 8 times 2 is 16. So the answer, x equals 16. You should always check these answers. They didn't ask you to check, but logarithmic log, you should always check also. If I do a quick check, log base 8 of 16, is that really 4 over 3? Yeah, so that's a little tricky to check it, but anyway, it's a little tricky to check because it doesn't ask you to check. I'm not going to check it over here. But you should get 4 over 3 if you check it into your calculator. If you put it into your calculator, you should get 4 over 3 or 1.33 something. All right, I'm going to go to the next question because I don't want to waste too much time. So I'm going to erase the board now. Let's look at the next question. Question number 19, right? Okay, so let me see if I can move this up a little bit for you. All right, question number 20. Right, question number 20. Yeah, question number 20. All right, so 20, let's do 20. So we want to solve for x to the nearest 1,000. So we have 3 to the power of x is equal to 62. We could write this in logarithmic form, right? We could take log both sides or we can write in log form. So we know b to the power of x is equal to y, means log base b of y equals x. Log base b of y equals x. So here this in log form is log base 3 of 62 equals x. Now, if you have a calculator, you can use this if you have a calculator that has any base. If you don't have a calculator that has any base, you could also use the change of base formula. Log base b of a is all equal to log base c of a divided by log base c of b. All right, so you could change the base as ln or log. So I'm going to use log. So log means base 10 of 62 divided by log base 10 of 3. Or you could use ln. ln 62 divided by ln 3 is x. Let's use our calculator and find the answer here. So let me go back to my Desmos calculator. Where is my Desmos calculator? Okay, so let's come back here. So I'm going to type log. Do I have log? I guess I got to go to functions. I think I should be able to type log. So log 62 divided by log 3. The answer I got that. So let me write to the nearest something. I'll check what that is. So, but x is approximately 3.7566. This is question number 20. So to the nearest thousands is 757. Okay. All right. I think that should be good for that question. Now let's look at 21. Let's look at 21. All right. So I'm going to erase the board. So we have log base 2 of x plus 4 equals 3 minus log base 2 of x minus 3. We want to solve for x. Now let's bring all the logs to one side. So let's move this to the other side by adding this. So we have log base 2 of x plus 4 plus log base 2 of x minus 3 equals to 3. Now we know sum of two logs is a multiplication of one log. So log base 2 of x plus 4 times x minus 3 equals 3. Now we can write the log as an exponential form. So 2 to the third power is equal to this. So let me write that. 2 to the third power equals x plus 4 times x minus 3. Now FOIL this out. 2 to the third power is 8. 8 equals x squared minus 3x plus 4x minus 12. That's a 4x, by the way. So subtract 8 on both sides to get 0 equals x squared minus 3x plus 4x is plus x. Negative 12 minus 8 is negative 20. So we need to find two numbers that multiply to negative 20 and add to 1. So the numbers are x plus 5 times x minus 4 equals 0. So the two answers are x plus 5 equals 0 or x minus 4 equals 0. So here, subtracting 5 on both sides, x is equal to negative 5. Adding 4 to both sides, x is equal to 4. You can check these. Let's check. Now, we know that for the logs, inside has to be greater than 0. So if you check the first one, log base 2 of negative 5 plus 4, as you can see, we get a negative 1. So this is not possible. If you put this into your calculator, it's going to be a domain error or an error. So that definitely doesn't check out. So first one does not check out. So reject this one. Let's check the other one. Let me see if I can check the other one. So log base 2 of 4 plus 4, is it really equal to, right? So that's log base 2 of 8, by the way. Let me do the left side only first. That's equal to log base 2 of 2 to the third power. So that's just 3. So left side is 3. Let's look at the right side. 3 minus log base 2 of 4 minus 3. So 3 minus log base 2 of 1. We know log base 2 of 1 is 0. So 3 minus 0 is 3. So left side is equal to right side. So that check is good. So the only answer is 4. So for 21, the answer is 4. Let me check the answer. 21 is 4 is correct. All right, let's look at the next question. All right, so the next question is 22. We are given f of x, which is equal to x squared minus 7x plus 4, right? We want to find what f of 0 is first. So substitute x for 0. So 0 squared minus 7 times 0 plus 4. Now all these are zeros. The only what's remaining is a 4. So f of 0 is a 4. Let's do f of negative 3. That's negative 3 squared minus 7 times negative 3 plus 4. That's going to give you 9 plus 21 plus 4. That's 34. And then f of 2t is going to give you 2t squared minus 7 times 2t plus 4. That's going to give us 4t squared minus 14t plus 4. And that's the answer because they are not like terms. You can't combine them. So let me check 23 answers. 23. Was that 22? That's 22. I'm sorry. So the 4 is correct. 34 is correct. 40 squared minus 14t plus 4 is correct. Okay, good job. I actually said good job to myself. All right, that's okay. All right, so number 23, right? So we want to find the domain. We know this is a rational function. So we have f of x is equal to 1 over 5 minus 4x. We know domain for a rational function, the denominator can't be 0. So 5 minus 4x should not be 0. Okay. So so that means I could add the 4x to both sides. This cancels out. 5 equals 4x divided by 4. So x should not be equal to 5 over 4. Right? X should not be equal to 5 over 4. So this as in interval notation first. So if you have a number line, we should avoid 5 over 4. We should avoid skip. So this side is good, that side is good. So first side is negative infinity to 5 over 4. Union, second side is 5 over 4 to infinity. Because we are putting the parentheses, we are skipping it over. Okay. We also want us to write in set builder notation. Let me see if I can show it to you. I want you to write in set builder notation. So the set builder notation is actually easier. I'll say set builder notation. We could say x such that x is not equal to 5 over 4. We basically copy this down. All right. So that's set builder notation. All right. I think I'm going to erase this and then go to the next question. Let me also move this up a little bit here. All right. So 24. Let's look at 24. All right. So let me erase. So 24. So we want to solve this system. So solve. So 4x minus 2y equals 16, as well as negative 3x minus 5y equals 1. So first, let's try to eliminate the x over y. So if you want to eliminate the x, 4 and negative 3 can least common denominator, least common multiple is negative 12 or 12. 2 and 5 you can make 10. So it doesn't matter what you want to multiply to cancel the x or y first. I'm going to do 12. So I'm going to multiply this by 3 and that by 4. Now remember, it's one is positive, the other one is negative. So it will eliminate. You don't have to change the sign. So distribute the 3 into all of them, however. So 3 times 4 is 12x minus 6y equals 3 times 16. 48. Okay. And then multiplied by 4, we'll get negative 12x, negative 20y equals 4. Now, as you can see, positive 12x, negative 12x cancel each other out. Negative 6y minus 20y is negative 26y equals 52. Divided by negative 26 on both sides to get y equals negative 2. When y is equal to negative 2, we can solve for x by substituting to one of the original equations. I'm going to pick the first one for no reason. I guess the second one is easier, but anyway, 4x minus 2 times negative 2 equals 16. 4x plus 4 equals 16. Subtract 4 on both sides. 4x is equal to 12 divided by 4. X equals 3. So the answer is 3 comma negative 2. We should check this, especially on the second equation, because we used the first equation to solve for the x. I'm going to check the second equation only, but you could check both. So negative 3x minus 5y equals 1. We want to check. So negative 3 times x is 3 minus 5 times negative 2. Is that really 1? Negative 3 times 3 is negative 9 plus 10. Is that 1? Yes, that's 1. So 1 equals 1. The check is good. So the answer is 3 comma negative 2. Let me check the answer for number 24. 3 comma negative 2 is correct. Okay, let's look at the next question. All right, let me erase the board here. 25. We want to solve for x and write in interval notation. So solve. We have negative 12 is less than or equal to 3x minus 2 less than 7. So here you can write this 2 separate inequalities or 1 inequality. The answer what we need is we need an x in the middle. So add 2 on all the sides. Cancel this out. So we have 3x is greater than or equal to negative 12 plus 2 is negative 10. Less than 7 plus 2 is 9. Now divide on 3 on all 3 sides, including the middle. So 3x divided by 3 is x, what we want in the middle. 9 divided by 3 is 3, greater than or equal to negative 10 over 3. 10 over 3 can't be reduced, so leave it as an improper fraction is fine. So as an interval notation, we want bracket negative 10 over 3, that because they have an equal sign here, comma 3, there's no equal sign, so a parentheses. Let me just read the question, whether they want an set builder notation or do we have to graph it? No, you just have to solve it. That's correct. Let me look at the answer for 25. 25, I can't even find the answer. Okay. Yeah, they have it in a little bit different way on the review sheet, but that's the final answer. Okay. All right, let's look at number 26. I'm going to erase the board. Let's look at 26. All right, so 26, we have this equation, 6x minus 3y equals 12. We want to find a line that's parallel to this line and passes through this point. All right, we want to find this in the slope-intercept form. We want to graph this. We want to label the x, and we want to also find the x-intercept. Determine the x-intercept. Okay. All right, so let's write y equals mx plus b form first. Y equals mx plus b form, so we can identify the slope of this one. So let me subtract 6x on both sides. So 6x minus 6x cancels out. Negative 3y equals negative 6x plus 12. I wrote negative 6x first because I want to have mx first. Now let's divide by negative 3 everywhere. So we get y equals negative 6 divided by negative 3 is positive 2x minus 4. Here, this looks like y equals mx plus b, where the slope or the m equals 2, and the y-intercept is negative 4, which is 0, negative 4, by the way. We only need the slope. So if the slope of the first one is 2, we know we are finding a parallel line. So the slope of the second one is the same as slope of the first one, which is also 2. Now we can see that this passes through the point 2, negative 3. We want slope-intercept form, so I'm going to write y equals mx plus b, which is 2x plus b. Now this equation has a different y-intercept, or should have a different y-intercept. So let's substitute and find the y-intercept. So don't use the same y-intercept as negative 4 from earlier. So y is negative 3 equals 2 times x is 2 plus b. So negative 3 equals 2 times 2 is 4 plus b. Subtract 4 on both sides to find your new y-intercept, which is negative 7. So equation of the line that's parallel to the given line is y equals slope is 2x minus 7. That's the answer for the first part. Let me just check. I just don't want to continue with the wrong answer. This was 26. Y equals, what do they want? Slope-intercept form. Oh, part A wanted into point slope form. So this is part B. This is part B. B is y equals 2x minus 7 is part B. I'm sorry. So for part A, we want to have, so this is slope-intercept. So point slope form is y minus y1 equals m times x minus x1. So let's substitute the point, which is 2, negative 3. So y minus negative 3. Remember the point was 2, negative 3. So this is our x and that's our y. Y minus negative 3 equals slope was 2 times x minus 2. So what? Minus a negative is a positive, so y plus 3 equals 2 times x minus 2 is the point slope form. This is the point slope form. However, if you distribute the 2, you could also find the slope-intercept form that way. Y plus 3 equals 2x minus 4. And by subtracting 3 on both sides, you get y equals 2x minus 7 from that way, also the slope-intercept form. Now we need to graph it. Now I need some space to graph it. So what am I gonna do? That's a good question. I might have to erase this. So I'm gonna actually erase this to do the next part because I need space. Okay, so Do you want me to manage? No, I think I should erase it. So let me erase it. So y equals 2x minus 7 is the equation. So 26 continues. The equation was y equals 2x minus 7, I believe. Okay, 2x minus 7. So here, remember the slope was 2. In other words, it was 2 over 1, rise over run. You got to use the slope as rise over run. And the y-intercept is where the graph crosses the y-axis, 0, negative 7. So what you should do is you have to first graph this like that and label them, I guess. So 0, 1, 2, 3, 4, 5, 6, 7, and so on. 1, 2, 3, 4, 5. That's negative 5. 6, 7, and so on. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, negative 5, 6, 7. Hopefully on the exam you get a graphing paper, or on the paper itself they might put your graph. So 0, negative 7 is here. The y-axis, 0, negative 7. And then you have to go up to the right one, right here. Up to the right one. You can do up to the right, and so on. So the graph should look something like that. And it has a positive slope. So it has to be going up like that. Okay. Now, where is it crossing the y-axis? Somewhere around here. I'm not even sure. It looks like up to over 1, up to over 1, up to. So, let me erase this again. Let me see if I can graph it a little clearly. Up to over 1, so it's at 1 here. And up to over 1 as at 2. Up to over 1 as at 3. Up to over 1 as at 4. So it looks like it's going between 3 and 4. So 3.5 in other words. All right. So let me come back. So we label that, and we label this as well. So this is y equals 2x minus 7. So that's part C, the graph. Okay. And then graph the result, label the axes, and indicate the appropriate scale. Okay, that's good. For the last part B, determine the x-intercept. Now, you could actually find the x-intercept from here. I'm going to guess it's 3.5, 0. Or in other words, it's 7 over 2, 0. It's better. However, how do I know for sure? For x-intercept, y has to be 0. So 0 equals 2x minus 7 is a better way of finding it without the graph algebraically. Now let's add 7 to both sides. So you get 7 equals 2x, divide by 2. As you can see, x equals 7 over 2 is the answer. All right. So as a coordinate, it's 7 over 2, 0. As I mentioned to you earlier, it's your x-intercept. All right, I'll do the next question. So let me erase this. Question number 27, right? So 27. We want to solve for B. We have 1 over A equals 1 over B plus 1 over C. First find the LCD. So the LCD is ABC. So we have 1 over A, let's multiply by BC. Equals, we have 1 over B multiplied by AC. Plus 1 over C has to be multiplied by AB. So we have BC over ABC equals AC over ABC plus AB over ABC. Now, by multiplying by ABC on either side, LCD cancels out. So we have BC equals AC plus AB. Now remember, we are solving for B's. Let's bring the B's together. So minus AB on both sides. So we have BC minus AB equals AC. Now B is in two places, factor the B out. So B times C minus A equals AC. Divide both sides by C minus A to get B equals AC minus C minus A. Okay, that's the answer. Any questions? I guess you could put it in the comments. Let me clear this. All right, so the next question. Question 28. We need to factor completely. So we have 8x to the power of 6 plus 27y to the third power. Now 8, we know it's 2 to the third power. X to the power of 6 is x cubed to the third power, right? So this is actually x squared to the third power, because 2 times 3 is 6. 2 to the third power is 8. Plus 27 is 3 to the third power. Y to the third power is y to the third power. Now the formula for a cube plus b cube is a plus b times a squared minus ab plus b squared. If you remember, so same, opposite, always positive. Okay, same, opposite, always positive. All right, so remember here, a is like 2x squared and b is like 3y. So let's see, a plus b, 2x squared plus 3y. I'll put a bracket, a squared, so 2x squared squared minus ab, 2x square times 3y. Finally, plus b squared, 3y whole squared. Okay, let's simplify that. 2x squared is 4x to the fourth power minus 2x squared times 3y is 6x square y plus 3y squared is 9y squared, and bring the 2x squared plus 3y down. And that's your final answer. Let me just make sure for 28, that's the answer. 2x squared plus 3y times 4x squared minus 6x squared y plus 9y squared is correct. Okay. All right, let's look at the next question. I'm going to erase the board. 29. Let's look at 29. So we need to simplify this. So we have 1 over x minus 1 over y divided by 1 minus x square over y square. So let's make 1 as 1 over y. Now you could find the LCD of all the fractions, or you could do the LCD for numerator and the denominator separately. I'm going to do it like separately because that's how we learned in class. So for the LCD for the numerator is x times y. So you have an x here, let's multiply this fraction by a y. So you get y over xy. This has a y, so let's multiply by an x to make the LCD. So you have minus x. On the denominator, the LCD is y squared. This already has a y square. So let's multiply this one by y square over y square. So you get y square minus x square over y squared. So now we have a fraction over a fraction. How do we simplify it? Keep, change, flip, keep, change, flip. So this is going to be equal to y minus x over xy times y square goes on the numerator, y square minus x square. Now we know that y square minus x square looks like a squared minus b square. Factoring of a squared minus b squared is a minus b times a plus b, difference of two squares. So we get y minus x over xy times y square over y minus x times y plus x. Remember here y is first, so when you're factoring, y has to be first. So now y minus x cancels. One y will cancel with one of these y's. So what do we have on the numerator? Only a y, this y, this y. One of the y's canceled out, but we have one y left. And then we also have another x on the denominator as well as y plus x. And that's your final answer. Okay. I'm going to erase the board and do the next question. Let's look at what number? Let's see. Number 30. So number 30, we have f of x, which is equal to cube root of 3x minus 8. We want to find f of 0. So that's cube root of 3 times 0 minus 8, right? That's actually 3 times 0 is 0, so cube root of negative 8. We know negative 8 is negative 2 to the third power, so cube root of. So cube root and cube cancels out, so the answer is negative 2. So f of 0 here is negative 2. Second part, f of 24. So f of 24 is cube root of 3 times 24 minus 8. That's cube root of 3 times 24 is 72, I believe. Let me check that. 3 times 4 is 12. To 1 carry forward. 3 times 2 is 6 plus 1 is 7. Minus 8 is correct. That's cube root of 64, I believe. Now, 64, square root of 64 is 8, but cube root means something to the third power. What to the third power is 64? 4 to the third power, right? 4 times 4 is 16. 16 times 4 is 64. So cube root of 64 is actually 4, okay? Not 8, but cube root of 64 is 4. So f of 24 is 4. Let me check these answers. Number 30, f of 0 is negative 2, as well as f of 24 is 4. That's correct, okay? All right, let's look at the next question. All right, let me erase 30 and do 34. Let me also move this up as much as I can. I think that's about it. All right, let's do the next one. All right, let me erase this as well. All right. So next question, 31. Let's look at 31. We want to rationalize the denominator. All right, so we have 6 over 3 radical x minus 2. We want to rationalize or to get rid of the radical from the denominator. We want to multiply by the conjugate. So the conjugate of the denominator is 3 radical x plus 2. Whatever you do to the denominator, you got to do to the numerator because of the fraction. So 3 radical x plus 2, we need to multiply. On the bottom or the denominator, we have a difference of 2 squares. So we have 3 radical x whole squared minus 2 squared. Now remember, that's because it's a minus b times a plus b is a squared minus b squared again. All right. So on the numerator, let me leave it as it is. So sometimes it reduces it with the denominator. So let me not distribute for now. If it doesn't reduce, I'll distribute. So 3x squared, 3 squared is 9, right? Actually, it would not reduce because you have x in the denominator. But anyway, so 9 radical x squared is x, right? So keep that in mind. Radical x squared, you square root and the square cancels out, minus 4. On the numerator, we have 6 times 3 radical x plus 2. You could leave this as your final answer, or you could distribute the 6 and get 18 radical x plus 12. 6 times 3 is 18, 6 times 2 is 12, divided by 9x minus 4 as your final answer also. Both of them are good final answers. Let me see what they have. 31. 31, if I can find it. 18 radical x plus 12 over 9x minus 4 is the final answer. They have. Okay, good. I hope that makes sense. Let me look at the next question. Let me erase the board. And let's look at next question. All right. So question number 32, I believe. Let's do 32. All right, is that 32? Hopefully it's 32. Yes, 32. X is positive or the variables are positive. We need to simplify the square root of 24 x to the power of 9 and y to the power of 6. Now, when you have square roots, it's the index or the exponent is 1 over 2 because index is 2. 24, does it have a perfect square factor? Squares are 4, 9, 16, and so on. So this has a 4, right? So we can do square root of 4 and 6. X to the power of 9, we can simplify that as x to the power of 8 times an x. Y to the power of 6 is already a perfect square. So y to the power of 6 is good. So square root of 4 is 2. So radical 6 remains. Here, x to the power of 4 squared and square root, and this cancels out. So we have x to the power of 4. Then we have a radical x remaining. And this is y to the power of 3 squared. Again, the square root and this cancels out. So we get y to the power of 3. So we basically will have 2x to the power of 4, y to the third power, and then the square roots are 6x. Let me just confirm the answer for 32. 2x to the power of 4y cubed, square root of 6x is correct. Okay. Let me see if I can simplify the next one close to this, 33. All right. So we have 2 radical 9 minus 5 radical 3 minus radical 75. Now radical 9 is 3. That's a perfect square already. So it's 2 times 3 minus 5 radical 3. 75 has a perfect square factor of 25 times radical 3. 25 times radical 3. 25 times 3 is 75. So 2 times 3 is 6 minus 5 radical 3 minus square root of 25 is 5 radical 3. Now these are like terms. So we have a 5 radical 3 and a 5 radical 3. So that's 6 minus 10 radical 3 is the final answer. Now 6 minus 10 you can't reduce because 6 doesn't have a radical and 10 has a radical attached to it. So they're not like terms. So 33 answer is 6 minus 10 radical 3 is correct. Okay, let's look at 34. Let me erase the board. So 34. So 34 we want to solve and check. We have cube root of, right? Cube root of 5 plus 3x equals negative 4. So let's cube both sides first because the cube root is already isolated. Cube root of a cube cancels each other out. So we'll have 5 plus 3x equals negative 4 to the power of 3. Negative 4 times negative 4 is positive 16 times negative 4 is negative 64. Now let's solve for x by subtracting 5 on both sides first. So we get 3x is equal to negative 69 divided by 3, which is x equals negative 23. Let's check this as well. Check with x equals negative 23. So we have cube root of 5 times 5 plus 3 times negative 23. We want to check if it's really negative 4, right? So it's cube root of 5. 3 times negative 23 is negative 69. Is that really negative 4? 5 minus 69 is negative 64. You know cube root of negative 64 is negative 4. And that check is good. If you didn't know negative 4 cube, you can check it out. Cube root k cancel each other out and you get the negative 4. So it checks out. Okay, so the answer is negative 23. Let me check for 34. The negative 23 is correct. Now let's look at the next question. I'm going to erase the board. All right, so next question is 35. 35, we want to write 5i over negative 2 plus 3i in the form of a plus bi form. So multiply by the conjugate. So 5i over negative 2 plus 3i multiply by the conjugate, which is negative 2 minus 3i. Numerator and the denominator, negative 2 minus 3i. So the denominator is a difference of 2 squares. So you get negative 2 squared minus 3i squared. So remember, it's a plus b times a minus b. Again, it's a squared minus b squared. On the numerator, you can distribute. So you get negative 5i times positive 5i times negative 2 is negative 10i. 5i times negative 3i is negative 15i squared. Everyone knows again, I square is negative 1. So let's simplify this a little bit. So we have negative 10i minus 15 times negative 1 is the numerator. Negative 2 squared is positive 4 minus 9i squared is in the denominator. So we have 4 minus 9 times negative 1. That's 4 times negative positive 9. That's a 13. So on the denominator, we have a 13. Negative 15 times negative 1 is positive 15. I'll write on the front minus 10i. Now we want to write this as a plus bi form. So let's separate. So we have 15 over 13 minus 10 over 13i. Let's put the I in the middle. So that's your final answer. Let me check this 35. 35 is 15 over 13 minus 10 over 13i is perfect. Let's look at 36. Okay, so let me erase the board. 36. Solve by completing the square. Now, if they ask you to solve by completing the square, do not use quadratic formulas. Don't use x equals negative b plus or minus square root of b squared minus 4ac all over 2a. So do not use that. So if you use that, I usually give only, I don't give any points, I give 0 points. So make sure you don't use that. So x squared minus 6x plus 3 equals 0 is what you have to solve. So this is how you solve by using completing the square. So you subtract the 3 on both sides to move the 3 to the other side. So you basically have x squared minus 6x. Let's keep a small space for complete the square equals negative 3. Now, here a is 1, b is negative 6. We want to do b over 2 first, so negative 6 over 2, which is equal to negative 3. And you want to do the b over 2 squared. That's what you want to add to complete the square. So negative 3 squared is positive 9. So add a 9 to both sides of the equation. So on the left side, we have x minus 3 and x minus 3. So it's x minus 3 whole square. Also, this would be always here. Equals negative 3 plus 9 is positive 6. Okay. Now, when you have this, you have to use the square root property. Put the square root on both sides, plus or minus. Square root of a square cancels out. X minus 3 equals plus or minus square root of 6 is what we have. Add 3 to both sides to solve for x. So the final answer is x equals 3 plus or minus root 6. We have two answers. One is 3 minus square root of 6. The other one is 3 plus square root of 6. Let me check this answer. 3 plus or minus square root of 6 is correct. Let me erase the board. Next question. All right, so next question, that is question number 37. But a hypotenuse of a right triangle. So let me draw a right triangle. Right triangle looks something like that with a right angle. The hypotenuse of a right triangle is 7 feet long. So this is 7 feet long. So the hypotenuse is given to us as 7 feet. One leg is 4 feet shorter than the other. So if one leg is x, the other one is x minus 4 because 4 feet shorter than the other. The question is find the legs to the nearest hundredth, second decimal place. We know if you have a right triangle, we can use the Pythagorean theorem. So if this is C, this is A and B, Pythagorean theorem is leg 1 square plus leg 2 square is equal to hypotenuse square, or in other words, A square plus B squared equals C squared, famous. All right. So in other words, this is x square plus x minus 4 squared equals 7 squared. Now we need to solve this. So x squared is already good. Here x minus 4 squared, either you can write it twice and simplify it, or if you know a minus b whole squared formula, which is a squared minus 2ab plus b squared, you could also use that. But if you don't remember that, x minus 4 whole squared is x minus 4 times x minus 4. X times x is x squared minus 4x minus another 4x plus 16. So you get x squared minus 8x plus 16. So we have x squared plus another x squared minus 8x plus 16 equals 7 times 7 is 49. So then x squared plus x squared is 2x squared minus 8x. Let's subtract 49 on both sides to bring it to one side. 49, 49 cancels. That side is a 0. 16 minus 49. Is that a 33 negative? I believe so. This one can't be reduced. So here A is 2, B is negative 8, C is negative 33. So use the quadratic formula is better. X equals negative B plus or minus square root of B squared minus 4AC all divided by 2A. Let's substitute. Negative negative 8 plus or minus square root of negative 8 squared minus 4 times 2 times negative 33 divided by 2 times 2. Let me simplify over here. So x equals positive 8 plus or minus square root of negative 8 squared is positive 64 minus 4 times 2 is 8. 8 times 33. 264. So positive 264 over 2 times 2 is 4. right? So we're going to get 8 plus or minus square root of 264 plus 64. That's square root of 328 divided by 4. So we have two answers. One is 8 minus square root of 324 over 4. This will give us a negative, so reject this one. Or the other one is 8 plus square root of 328 divided by 4. So let's do the square root of 328 first. 328. You get 18 point something plus an 8. Then divide that by a 4. We want to round to the nearest hundredth, second decimal place. So I get 6.53. 6.53 is x. So the other leg is x minus 4. That's 6.53 minus 4. That's 2.53. I believe both of them are feet. Let me confirm this. That's question number 37. 6.53 as well as 2.53 is correct. Good. All right, last question on this page. I'm sorry. I hope you had time to look at it. All right, I guess you could post it again. All right, let's look at the next one. Last question on this page, which is 38, I believe. We have f of x, which is equal to negative x squared plus 4x plus 5. What do we have to do? Let's see what we have to do. Is it on the other page, what we have to do? For the function this, let me see if I can find, look at the other page. I might take it to the next one. Let's see. What do we have here? Yeah, can we find it quickly? Yeah, I guess we have some steps. So I'm going to do that on the next page. Okay. So, all right. So I'll see you on the third page. For now, I will stop this one.